Welcome back to Physics 101. Today, we would be covering Chapter 14 on periodic motion. Since it's our first question, we'll start with a simple one and work our way up. So here in our first question, we have an object that is on a frictionless surface attached to a string, displaced, and then released. As a result, the object will oscillate and the displacement would be 0.20 meters from its equilibrium and 0.20 to the other side, and it has passed the equilibrium once during this interval. And we are asked to find three things: the amplitude, the period, and the frequency. Based on the information we read in the book, we know that the concept of amplitude is the maximum displacement from the equilibrium. The question states that the object goes from x distance and x distance to the other side, back during one cycle. So our amplitude would be 0.20 meters. Now, for finding the period of our motion, in our question, it stated that the time it took for the object to move from positive 0.120 to negative 0.120 was 0.8 seconds. We know that the motion from the maximum positive displacement to the maximum negative displacement takes place during half the period of SHM. So, the formula for calculating our period would look like this: 0.8 seconds is equals to time over 2. Now, isolating time, our answer would be 1.60 seconds. Now, to solve for our frequency, we would use the book. At equation 14.1, it states that frequency is equals to 1 over our period, which is 1.6 seconds. Our final answer would be 0.625 hertz. Now, for our second question is quite similar to our first question, but now we are relating it to biology. In our second question, it states that the wing of a blue-throated hummingbird beats at the rate of up to 900 beats per minute. We are asked to calculate the period of the vibration of the bird's wings, the frequency of the bird's vibration, and lastly, the angular frequency of the bird's wing beats. To find the period of the motion, we are given that the wing of the blue-throated hummingbird beats at the rate of up to 900 times per minute. Since the time taken to complete one beat will be the time period of the vibration of the bird's wings, hence our time would be 60 seconds over 900 beats, and we would have the answer of 0.067 seconds per beat. In solving from the frequency of the wing's vibration, we can solve this in two different ways. The first method would be the number of beats completed in the time 1 minute. Sorry for the typo, it's supposed to say 1 minute, not 1 second. Moving on. The number of beats completed in 1 minute would be our frequency of the bird's wings vibration. Hence, our frequency would be 900 vibrations over 60 seconds. We would end up with the answer of 15 beats per second. Now, for the second method, we would be using the previous equation we used last time, which is frequency is equals to 1 over our period. And this would be 1 over 0.067 seconds. And we would end up with the same answer of 15 beats per second. Now, for our angular frequency, just like how we solved our frequency, we can solve this in two different methods. One would be using our time and one would be using our frequency. When we would be using time in solving for the angular frequency is equals to 2 pi over time. However, when we would be using our frequency, angular frequency is equals to 2 pi times our frequency. Plugging in all our values, we would have the final answer of 94.25 rad per second for our angular frequency. For our question number 2, it teaches us how the elements of motion relate to each other and that we can solve each problem using different methods. Now, for our last question, the object is undergoing SHM with a period of 0.9 seconds and the amplitude of 0.32 meters. At time equals 0, the object is at x equals 0.32 meters and it is instantaneously at rest. We are asked to calculate the time it takes for the object to go to A from x equals 0.32 meters to x is equals to 0.16 meters and B from x is equals to 0.16 meters to x is equals to 0 meters. To calculate this, we know that the displacement in simple harmonic motion as a function of time is given by x is equals to a cos quantity omega times time minus sigma, where a is the amplitude, omega is the angular frequency, t is the time, and sigma is the phase angle. And that would be our first equation. Now, given that the period of simple harmonic motion is time is equals to 0.9 seconds, since the angular frequency is given by omega is equals to 2 pi over time, where omega is our angular frequency. Therefore, from equation 2, we get omega is equals to 2 pi over 0.9 seconds. We would end up with the answer of 6.98 rad per second. The amplitude is also given at 0.32 meters. Let us consider here that the phase is 0, i.e. sigma is equal to 0 degrees. So from our equation 1, we would get x is equals to 0.32 meters times cos quantity 6.98 rad per second, our omega, times time. And this would be our third equation. Now, to calculate the time taken by the object to go from x equals to 0.32 meters to x is equals to 0.16 meters, we would use equation 3. Let time t is equals to 0 seconds and the object is at x is equals to 0.32 meters. And at later time, which is time 1, it is at 0.16 meters. Hence, from equation 3, we would get the time t1 at which the object is at x equals to 0.16 meters. By isolating our t1, we would get the answer of 0.15 seconds. Now, the total time taken by the object to go from x is equals to 0.32 meters to x is equals to 0.16 meters would be the change in time is equals to the final time minus the initial time, which is equals to 0.15 seconds. Now, for the other half of our question, to calculate the time taken by the object to go from x is equals to 0.16 meters to x is equals to 0 meters, we will again use the equation number 3. But in this case, the amplitude will be a is equals to 0.16 meters instead of a is equals to 0.32 meters. Let at time t1 is equals to 0.16 seconds and the object is at x is equals to 0.16 meters. And the later time t2, it is at x equals to 0 meters. Hence, from the equation 3, we will get the time t is t2 at which the object is at 0 meters. So, plugging in all our values and isolating t2, we would end up with a final answer of 0.225 seconds. Now, the time taken by the object to go from x equals to 0.16 meters to x equals to 0 meters will be, again, the final time minus the initial time. And we would end up with the answer of 0.075 seconds. Now, this would be the end of our class. It's too bad that's all the time we have for today. Thank you so much for listening and hope I was able to help your physics journey. Tune in to more physics solving fun.